Electric vehicles with fuel cell powertrain have very high potential to fulfill the needs for a sustainable mobility of the future. They have a very high efficiency and can be fueled with pure hydrogen. Moreover, they don't produce any emission while driving. The range of fuel cell vehicles is rather high in comparison to other electrified vehicles, and furthermore, the fueling time is short. Additionally, hydrogen technology and fuel cell drivetrains contribute to the climate and energy policy of the European Commission.
The discussion of transportation in the future is marked by 5 key factors. First, the reduction of greenhouse gas emissions. Second, the energy security. Thirdly, the increasing energy efficiency. Fourth point is improvement of the life of the inhabitants, and not to forget the last point, which is competitiveness of the European industry. As hydrogen can be produced from a variety of energy sources, it contributes to a significant reduction of CO2 emissions because it can be produced by renewable energies. Additionally, the large primary energy sources for hydrogen production contribute to the energy security because hydrogen can be produced everywhere in the world and is no longer dependent on regional focused supplies like crude oil. The high efficiency of the fuel cell powertrain contributes to a significant reduction of the energy consumption for transportation sector. Not to forget the low noise emissions, which contribute to an improvement of the life of the inhabitants. And lastly, the European industry and academia is already in a very good position in the range of fuel cell technology and hydrogen technology. Therefore, fuel cell technology and hydrogen can contribute to a higher competitiveness of the European industry.
HySYS is a research and development project which is founded by the European Commission. Partners of the HySYS project are coming from the automotive industry, the supplier industry and academia. The goal is to improve system components and subsystems for fuel cell and hybrid vehicles.
These components can also be used for other electrified vehicles like battery vehicles and plug-in hybrid vehicles.
Once the components are developed, these will be integrated into validator vehicles in order to test the entire system. HySYS is a joint project of 28 partners out of 9 European countries. The project started in December 2005 and will end in November 2010. It is coordinated by Daimler and has a budget of €22.7 million. From this, €11.2 million are funded by the European Commission.
The main objective of the HySYS project is to develop system components for fuel cell drivetrains and hybrid electric drivetrains. On one side, we are working on fuel cell system components, on the other hand, on electric drive components. We are focusing on the most important fuel cell and electric drivetrain components, which have the highest potential for cost reduction and mass production. The approach is to reduce complexity and use innovative approaches. This is done by improvement of fuel cell technology and electric drive technology in respect of functionality, reliability and cost. The optimization of system architecture and energy management contributes to a reduction of energy consumption and increase of power density.
On the fuel cell side, we are focusing on 4 components: the air supply, a novel humidification system, a new hydrogen sensor concept and an innovative hydrogen supply line including hydrogen pump and metering. On the electric drive system side, we are working on all important electrical components: the electric motor, the power electronics and the battery. When we look at the air supply system, the key component is an electrical turbocharger with a very high efficiency. However, the costs for this advanced air supply system are relatively low So is its volume and weight. In addition, the turbocharger has a high dynamic response and produces very low noise during operation. The humidification system is based on a gas-to-gas humidifier with a high packaging density. At the same time, we have high humidification efficiency and low degradation tendency, although we are using low-cost materials and an easy production technology. The new hydrogen sensor concept uses palladium nanostructures. The results are low costs, volume and weight. The sensors have a very fast response and no calibration is needed anymore. The concept assures a high gas selectivity and an integrated design. In the vehicle, we have integrated a fully automated hydrogen line, including an innovative hydrogen metering. It allows for a dual-stage pressure reduction and a fully automatic operation. Furthermore, the fuel cell stack pressure can be regulated more easily. A failure recovery supports the system's safety. And last but not least, the overall lifetime of the fuel cell system has been improved. When we look at the electrical motor, we decided to go for buried PM synchronous and mixed motors that have higher specific torque power efficiency. Regarding power electronics, we focused on a modular solution with high power density. This could be achieved by better integration of these components and a higher cooling temperature of up to 90 degrees Celsius. The innovative lithium-ion battery is a key component for the electric drive system. The battery has a specific power of 2 kilowatt per kilogram and a specific energy of 63 watt-hour per kilogram. The efficiency reaches up to 95% with a lifetime of about 15 years. In addition to the development of the components themselves, we are working on a standardization of these components too. At the same time, we are looking for synergies between fuel cell and hybrid vehicles. Safety is another very important aspect, both for hydrogen and electric safety. Not to forget the optimization of control strategies and energy management, which lead to a significant reduction of energy consumption.
HySYS can pave the way towards commercialization of fuel cell and electric drive systems.
The availability of low-cost components is important to be able to produce such vehicles for the mass market. Close cooperation between the supplier and automotive industry is the key for this issue. HySYS is an example of how this cooperation can be done.